Hi there, let's have a quick look at this question. So it goes here, diagram shows a plank of wood, AB, mass 10 kg, length 6 meters, resting with its end A on a roof. Okay, so end A, this has got roof, so there's friction pushing down there. Just going to quickly put that there. So resting with its end A on rough horizontal ground and its end B in contact with a fixed cylinder oil drum. So from here, so that will push upwards perpendicularly and report reaction of B. Okay, the plank is at the vertical plane perpendicular axis of the drum. It's up at the right, so that's just there. Line AB is tangent to that. Okay. Cross section of the drum with the point of contact is B. Okay. Plank is inclined at theta. Where theta is that? Okay. Right, that's okay. So that's perpendicular to that, so that will go through the center here. That goes through there. Okay. And this is 90 degrees here. Just put that there. Right. So let's begin this question. So find in terms of G the contact force between the drum and plank. Okay, so we need to find that. So what we can do is, before we need to find the angle in this term. So basically, if that's saying, if that is tan theta, let's just draw tan theta here. So that was theta. So tan theta would be opposite over adjacent. Now you should know that this is a typical Pythagorean theorem. So that's 5 squared is 25 plus 12 squared is 144. So 5 squared plus 12 squared square rooted, that's 144 plus 25 is 169. And if we square root that, we get 13. So now when that's 13, we can then from here easily get that sine theta is going to be opposite of our hypotenuse, which is 5 over 13, and cos theta will be adjacent over hypotenuse, which is 12 over 13. Okay, we'll come back to those in a second. So now if we take the moment about here, so moment about A, then what do we know? That the plank is uniform. Okay, it's uniform, so that means the center of mass will go halfway down, so that will be mg, which is 10g. This length here will be 3 meters because it's uniform, so it's in the middle. And right, and that's smooth, there's no friction there. So if we take the moment at A, we ignore all the forces going through A, so this will be going down and that will be pushing up. Now this is perpendicular to this force. Okay, I'm just going to draw that again. So this is going perpendicular to this length. That's easy enough. And so that force is perpendicular to that. However, this force is not perpendicular to that, so what we need to do is from A, take the perpendicular length, which will be this one, and we need to find this length, which will be perpendicular to this force going downwards. Now that is going to be 3 multiplied by sine, no sorry, this is sine, so this is cos theta. So that's 3 cos theta. Okay, hypotenuse times cos theta. So that's the adjacent, that's the opposite. So we've got 3 cos theta times 10g. So that's forces going clockwise and anti-clockwise. We've got 6, that's the length, so that's the distance is 6, which is perpendicular to this force pushing up, so that will be 6 times r at B. So now we know that cos theta is going to be 3 times 12 over 13 times 10g, and we'll take that 6 down. Oh, let's just do this at the moment. 6rb, so that's going to be 36 360 360g over 13, and then take that 1 6 over, so that will be the reaction at B. So it goes normal contact between the drum and the plank will be that RB. So therefore, if you put that in your calculator, you'll get just give me 1 second. 360 over 13 multiplied by 1 6, and you'll get 60 over 13 G. So that's the force that's being pushed out that way. Okay, so we're done with that. B marks, easy stuff. Next one. Given that the plank is at limited equilibrium, find the coefficient friction of friction between the plank and the ground. So what we've got here is friction pushing that way, and we've got the contact at A. Okay, now we've got this going down, which is the weight, and now this one, because we've got to take everything vertical and horizontal, this force here, when it's going this way, I'm just going to draw it out again. So this force is actually pushing upwards, then pushing that way. So you've got this going there and there. And note that this angle here is theta, because if we pick that go all the way down, and you got this going this way, okay, we know that. Okay, so we got that, and we know that if this is going down, that's going to be 90 degrees. Okay, and this will be same as the theta there. So how can I make this sound a bit better than what I'm trying to do? That's going there, that's going down. So if we took this one over here, this one over there, we know that this coming down will be 90, this will be theta, so this one will be theta 90 minus theta. Okay, and there's, we've got 90 degrees, so that must be theta. Okay, so we've got 90 minus theta, 90, and then this must be theta, because they're going to add up to 180. Okay, so that is theta. So in which case we've got a force pushing upwards, which will be RB has this measurement, so going up will be, so that's sine, and going up is cos. Okay, because that's opposite. So we've got a force going this way, which will be 60 over 13 G times, because that's opposite, so that will be sine theta. And this one's pushing up, so this is adjacent, so that will be 60 over 13 G cos theta. Okay, so those are the forces, and that's going upwards. So that's being pushed up, and then to the left, this is up, this is down, and friction is going there. Okay, to the right. So let's balance this out. So we know that, let's do the horizontal first. So horizontal forces, we know friction is going to balance with forces going that way. Now that's going up, it's that. So that's going to equal 60 over 13 G times sine theta. Now I know that sine theta is 5 over 13. So if I multiply this, you'll get 300 G over 169. Okay, so that's the friction. Okay, they were horizontally balanced. Now vertically, you got that going up, that going up, sorry, that going down, up, and this force is going up. So I've got RA plus, what else is going up? This is going up, so I've got 60 over 13g times cos, now cos theta is 12 over 13, and that's going to balance with that coming down, which is 10g. Now if you multiply that and rearrange it, so I'm just going to quickly do that, 60 over 13 multiplied by 12 over 13, you'll get RA plus 720 over 169 G equals 10G. So if you take that to the other side by subtracting it, RA is therefore going to equal, so take away what your answer was, it's going to give you 970 over 169 G. So that's RA. Okay, so we got that. Now we've been told it's at limiting equilibrium. That means its friction is at its max. And when friction is at its max, that will be mu times RA. So we know the maximum friction is going to be this, which is 300 G over 169. Mu we're going to calculate. RA is 970 over 169 G. Now, let's put a bit of red in here. Now we can cancel the G's out. Can times both by 169. I can divide that through, so you get 300 divided by 970, which will equal mu. So we can cancel those out, and therefore mu would equal 30 over 97. So I'm just going to quickly check this. 300 over 970, 30 over 97, and if you want it as a decimal, you could have it to 0.309. Okay, hope that helps.